It is time for the properties of the dot product of two vectors. Remember, this is in R2 and R3. These are boring but essential. At some point, if you carry on in math, you will have to prove them likely. But as it is, just running through them quickly before we use them on the next slide. Commutative property means that if you take the dot product of two vectors in, I'm going to say, a forwards order, even though there is no order, or a backwards order, you will end up with the same result. So if you take the x's and multiply them, the y's and multiply them, and if you're in 3 space, the z's and multiply them together, and then add them together, you will end up with the same regardless of which direction you do it in. The dot product has the distributive property. So if you're adding two vectors together to create a third vector, and then you dot it with a different vector, then that is the same thing as if you dot that different vector with each of them individually and then add. So that works. It looks like algebra. So it looks like this, but this is multiplying and we are doing dot product. So they are different, and you have to pay attention in math about what is distributive and what is not, and the dot product is distributive. The third thing, can't count this morning, is that if you dot a vector with itself, you end up getting the magnitude of that vector squared. So this one, actually I'd say this one and this one are pretty essential. And the last one is if you take, and I'm going to start at the back here, if you take two vectors and dot them, so come up with a scalar, and then take that scalar and multiply it by another scalar, that is the same thing as if you multiply each vector by the scalar and then dot it with the other one. So that has no name for it, as does this, but the property is true nonetheless. All right, so time for two quick questions. So I'm going to move 2 out of the way so I have enough space. I have no idea how much space 1 is going to take us, but it says expand and simplify. So we are allowed to do the distributive property kind of, sort of. So I am going to do this, but that implies multiplication back in the olden days of grade 8, 9, 10, 11, and 12 before today. What I'm going to do is I'm going to do this, but not with multiplying, but with dot product. So that means 4 times 9, 36, and u, vector u, dotted with another vector u. And that's because this is dot. Now, the next one is this. And this one will be -8. And u, from here, dotted with vector v from the second bracket. Then this dot product, so that's positive 45, v, vector v, dotted with vector u from the second bracket. And then last of all, and I know this looks like FOIL, but FOIL is multiplying, and we are not multiplying, we are dotting here. So -10 with the numbers, vector v dotted with the vector v from the second bracket. Now, if we go back to our properties, it doesn't matter which order you dot in, it is the same result. So that means this quantity and this quantity, at least this part of it, is identical. It doesn't matter that they're reversed. So I'm going to pick u then v, just because I find that easier to deal with. So 45 minus 8, or -8 plus 45, is positive 37. And like I said, I'm going to go with this version. And then another property that kicks in is this one, where we dot two vectors that are the same. It is going to be the magnitude of that vector squared. And that happens in two different places. It happens here with u dot u. So that can be replaced with this. And here's v dot v. And we get that. And that is as expanded and simplified as we can possibly get. Notice how when I mean dot, I'm saying dot, and when I mean magnitude, I'm writing magnitude, and all of this is happening with vector, 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 vector. So make sure you are clear with your communication. All right, now we get to do it again, but there's a little bit of math involved in this one. So I am going to start by doing the exact same thing. I am not going to read the question until a bit later. So let's take care of what we know. So this times this, but in our case, dot. So 10 vector u dotted with vector u. I'm going to get rid of these green arrows in a minute. That's 35 vector u dotted with vector v. Then this one is -6 vector v dotted with vector u. And last of all, -21 vector v dotted with vector v. So I'm going to get rid of all this because I do need to read what's underneath that. Before I start to read, I'm going to clean this up the same way as we did the question above. So 10 magnitude of u, vector u squared. 35 minus 6 doesn't matter the order because it's the same. So plus 29. I'm choosing to use u dot v rather than the vice versa version. And 21, -21 vector v magnitude squared. All right. So we have some stuff that we can put in. I'm going to do the first things in 0, and it says u and v are unit vectors. That means the magnitude of u is 1 because it's a unit vector, and the magnitude of v is a 1 because it's a unit vector. So I'm going to take this and turn it into a 1, and I'm going to take this and turn it into a 1. And there we go. Now the other thing that we know in this question is something that I overlooked as well, and that is the angle between them is 120 degrees. So what I can do is I can reach back into the old note of what dot product really is. I'm going to take a little break here, mostly because I'm going to squish in here, and I don't want you to witness me moving this stuff around. So give me a sec. Okay, that took a little bit longer than I wanted it to. Cos theta. All right, so I want to find this value as a number. And it shouldn't be surprising to you that we will end up with a number answer because the dot product result is a scalar. So I'm going to use all the information I know. So u dot v, which I want in this spot right here after a plus 29. So I want a value in that spot. I'm going to have to figure it out using this version of the dot product. So the magnitude of u is 1. It's a unit vector. The magnitude of vector u is 1. It's a unit vector. Cos 120 degrees. So what I need to do is I need to figure out, using the unit circle, what that is. So 0, 1 over 2, oops, root 2 over 2, root 3 over 2, 1, and that's the cos values. So this is 30. This is 45. This is 60. This is 90. There's 3 over here, so that's 30 degrees more, so that's 120. That's 135. That's 150. That's 180. And yeah, you got to do this if you're at a school that doesn't let you use a calculator. So this result is the same as this result for 120. And that means it's a half, but we have to figure out if it's negative a half or positive a half, and we're going left, so that's a negative a half. Also, because CA, only sign is positive there, and I'm being asked for cos. So 1 times negative a half is negative a half, which I can put in here. Okay, back to blue. 1 squared is 1 times 10 is 10. That will be negative 14 and a half, which is 20. Oh my gosh, I can't believe I did that in public. 29 over 2 minus 1 squared is 1 times 21 is 21. So that's negative 11 from my whole numbers. It's negative 22 over 2 minus 29 over 2, which is negative 51 over 2 for the answer to 5u minus 3v with vector symbols, dotted with 2u plus 7v. With vector symbols. So that is the overall answer. And what that tells you is not very much. It tells you that this vector, the result of taking 5 of these unit vectors and subtracting 3 of these unit vectors, and this vector, which is 2 of these unit vectors plus 7 of these unit vectors, the result of those two brackets is not perpendicular. Because remember, if you have perpendicular vectors, the dot product would be 0. So that's what that tells you. So I'm going to get rid of all my scribbles so you have no proof. I'll leave this here in case it's helpful. I do want to say that if you are going to a school that lets you use a calculator, you could, at this point right here, cos of 120, you could have very easily done 120 cos and got the negative 0.5, and you could have used your ABC button all down here. So it's not a big deal. I am trying to prepare some of you for where you're going. So that is all except for still R2 and R3 separate because that's the way your textbook is laid out.